Hi Pre-Cal Honors, so this is Notes 1.1, and we're going to start with our objectives here. You're going to be able to solve equations algebraically and graphically, understand hidden behavior, and be able to solve application problems, but really basic ones. Okay, so we're going to start right here with number 1, and then we'll talk about the zero factor property in just a second. So if I ask you for you to solve this, notice that we have a cubic, right? So I think, we've done these in the past where you go ahead and subtract the 11x squared and the 10x, and then you end up with 0 on one side of the equation. And this is actually, we're going to talk about the zero factor property, where a product of real numbers is 0 if and only if at least one of the factors in the product is 0. So now our job is going to be to factor. Okay, so we have 0 on one side of the equation. And again, I think we've been doing this type of problem for a while, and I guess we just didn't know it was called the zero factor property. But now we're going to go ahead and factor out the x and factor the quadratic. So now we've talked about how if you have x times 2x minus 5 times the quantity 2x minus 5 times the quantity 3x plus 2, you know that either x is 0, 2x minus 5 is 0, and 3x plus 2 is 0. And again, this is the zero factor property that you can say x is 0, 5/2, or negative 2/3. Okay, so we're going to go ahead and do another problem now. Go ahead and go to number 2. But before we do that, let's talk about this fundamental connection. So go ahead and read it. Pause the video if you must. Go ahead and read it to yourself and see if you can tell the difference between the root, the solution, the 0, the x-intercept, etc. Okay, so I think we might want to start here, where if I say a 0 or an x-intercept of the graph, I'm saying the same thing. If you have something like, I don't know, f of x equals x minus 1 times x plus 2. We know that this is a quadratic. You have x-intercepts at negative 2 and 1, and you could say, well, the zeros, or the x-intercepts, are negative 2 or 1. But then again, this might seem like a really minor thing, but if I say a root, that's actually something a little different. So a root is an equation in one variable. So let me explain what that means. So you might say something like x minus 1 times x plus 2 equals 0. Notice I didn't say equals y equals f of x, etc. So if I describe it like this and I say x equals 1 and x equals negative 2, those are roots or solutions to an equation. So again, when I say an equation in one variable, notice there are x's in this equation. There is not a y in this equation. So again, that might seem like a minor thing, but there is a difference. So what we're going to do right now is we're going to talk about number 2, and we're going to solve this one a little bit differently. Now, when I divide by 7, you certainly could expand x plus 8 quantity squared and get 0 on one side, etc. But for this one, I think it might be a little clever if you just notice that you have x plus 8 squared is 4. So that means that x plus 8 is either 2 or negative 2, right? Because 2 squared is 4, negative 2 squared is 4. So this might be a quicker way to solve this problem. And we still get the same 2 answers. Okay, so why don't we go ahead and try number 3. I'm just going to have you guys pause the video for a minute and think about how you would like to solve this one. Okay, so hopefully you did that. We squared both sides of the equation. Now we have this one radical over here. We isolate the second radical. Now, when it comes to this step, you can divide by 2 without getting something that's too ugly, so I would go ahead and do that. I don't think I would divide by the negative 4 and make it, again, make an ugly fraction. So we end up with negative 2x equals, and then our radical. So now if we go ahead and square both sides of the equation again, but realizing when you're doing this, you're possibly creating extraneous solutions. So we're going to have to check all of our answers later on. Okay, so now again, we're going to think about that property, that zero factor property. We're going to get 0 on one side of the equation, and we'll end up with 3x squared minus 7x minus 10. So again, if you factor this, you will get your answer. So go ahead and pause the video and factor. Okay, so we went ahead and factored, used the zero factor property, and we end up checking our answers. Now, if you check your answer, this one actually doesn't work, so we have one answer. But again, what a lot of work, right? So what I wanted to do is show you a graphical method, and we'll get the same answer. So go ahead and grab your graphing calculator. So if I go to y equals, there are a lot of ways you could do this. Now, I typed in to y1, I typed in the left side of the equation. And then on, let's see, in y2, I typed in the right side of the equation. So if you take a look at the calculator, I want to see where they're equal. Now, there are a lot of ways to do this, and you could have actually even, well, two ways I could think of right now. You could have gotten 0 on one side and looked for an x-intercept. But let's try it this way. So I'm just going to do a zoom 6 right now and look at the graph. So do you see how where those two expressions intersect, that would be your answer. And let's see, I'll move my answers over here. So I'm guessing it's at -1, but you see that those two equations, those two graphs, they do not intersect at 10/3. So again, the graph just confirms that 10/3 was an extraneous solution. Just to be sure, you should probably do intersect. There you go, moving from one function to the other. And guess, we'll take a look. Okay, so notice it is -1. All right, great job on that, my friends. So what we're going to do next is we're going to talk about hidden behavior. So you do need your calculator again. So why don't you pause the video and go ahead and graph 4 and 5 into your calculator, your graphing calculator, and see if you notice any hidden behavior. All right, welcome back. So I unhighlighted, if that's even a word, the y2, so we're rolling the graph one at a time. So first of all, I don't know if you were looking at this and you think, that's ridiculous, Mrs. Corbett. Isn't that just y equals x to the 1? Is that what you're thinking, right? But let's take a look at, let's take a look at what happens when we look at our calculator. So let's hit graph. I'm going to actually do a zoom 4, which is a smaller window. And there you go. Let's do a zoom 6. There you go. Okay, sorry, there was actually a typo in my notes because I realized when I graphed this, there was actually nothing hidden or exciting at all. This is a typo. It was supposed to be x to the 200 and then to the 1 over 200 power. But again, you're thinking, why is that interesting? But if we go ahead and hit graph now, if you take a look at the graphing calculator, something very interesting is happening. So if you got a little closer, you'd realize that, I'll get a different color, when you graphed, you had something like this going on. So what's happening is that your calculator is having some trouble. I'm just going to go ahead and do, let's see, a trace here. So if you hit trace, you realize that your calculator, if you take a look, for values very close to x equals 0, your calculator is just rounding to y equals 0. Okay, so that's what's happening here. So again, that's called grapher failure. Those numbers are just too small and your calculator rounded. Okay, let's take a look at the other one. So I'll go back to y equals, and we'll clear that out. And take a look at the second one. If you take a look at the graph. Okay, and you might say, I didn't actually, I think we, there we go. We need to do a zoom 6. So when you graph this one, you think, is this what the graph really looks like? There we go, I had to highlight it again. So take a look at number 5 then, and you think, well, this is a cubic. I certainly wasn't expecting to look like a quadratic. Right? So then you wonder, well, do I just have a bad window? So go ahead and try to adjust the window to see if there is more to this graph than it seems. Okay, so I made the x-axis from -25 to 25, and let's take a look. And if you can see, there is actually more to this graph than we originally thought. So I'm guessing that the graph goes like this. And again, you can adjust the y's and make the y much larger and then see the rest of the graph. So go ahead and pause the video and do that now. Okay, I actually made the y max really large, and notice I turned the y scale to 0, so you wouldn't have all those tick marks that would show for to make your axes really confusing, but there you go. Okay, so here's the next thing we're going to do, my friends. I would like to do one more word problem. We're going to compare cakes. So we have to figure out what would happen if you're comparing a rectangular cake to a round cake. Now it says 8-inch diameter, so that means 4 inches would be the radius. And it says that the round cake is twice the height. So we want to find out what has more cake for the money. So go ahead and length times width times height for a rectangle, and the area of the base times the height for the round cake. See which one has the larger volume. Okay, so I realize there's an x in there, but notice this is 117 x cubic inches, and this is 100.53 x cubic inches. So that means that more yummy cake for the rectangular version. Okay, so we're going to stop there. Have a great day and see you soon.